Problem 1.1, packet problems 1 through 9. So in this problem, it says another middle school conducted the same type of fundraiser, and the banner here shows the goals for each grade. So we have 5th grade, 6th, 7th, and 8th. It says write 3 statements that the principal could make when comparing the goals at each grade. Okay, so it says to write 3, I'm going to write 1, and you're responsible for the other 2. So I'm looking up here, and I'm going to say, okay, 5th grade, looks like if you double 120, you'd have 240. So the 5th grade, I'm going to say the 5th grade. I'm going to pause the video. So I'm saying, when I look at the 5th grade's 120 and the 7th grade's 240, 100% of the 5th grade's goal, 100% of it, all of it would be 120. But the 7th grade wants to get double that, so that would be like 200%. So I say the 7th grade wants to raise 200% of the 5th grade goal. You needed to have 2 others, and you can ask me if they're correct in class. Next question. The teacher set a goal of $225. Write 2 statements the principal could use to compare the goal to the 8th grade goal. Well, one way, when I looked at this problem, I thought, okay, if the teachers have a $225 goal and the 8th graders have a $300 goal, I wonder what that would look like if we made a ratio. Right now the ratio is 225 to 300. I wonder what the ratio would look like if we made an equivalent ratio but a lot smaller, an equivalent but a lot smaller ratio. So when I look at these 2 numbers, 225 and 300, I can figure out that the greatest common factor is 75. So if I divide both of those by 75, I get a ratio. 225 divided by 75 is 3, and 300 divided by 75 is 4. So I have a 3 to 4 ratio. So I could say, I'm going to pause the video, I can say for every $3 the teachers raise, the 8th grade raises $4. So I took a ratio, 225 to 300. I made it into an equivalent ratio by dividing each number by the greatest common factor, and I got a ratio of 3 to 4. That means that for every $3 the teachers raise, the 8th grade raises 4. Problem number 2. Bryce and Ryan collected canned goods for the local food bank. Bryce had 32 and Rachel had 24 items. Write a fraction comparing Rachel's number to Bryce's. So the way you should attack this number is you want to put Rachel's number first, Bryce's number second. Well, I'm going to first write it as a ratio. So what was it? Rachel had 32 items to Bryce's 24. And we can write it a second way, 32 to 24, or we can write it like the problem wants us to. It said write it as a fraction, 32 to 24. And can this fraction be reduced? So when you look at this fraction, you need to be thinking, what's the greatest common factor that both numbers share? And we know how to find the greatest common factor by doing factor trees, or you can just list them out. But I know the greatest common factor is 8, so if I say 32 divided by 8 and 24 divided by 8, I get a nice new fraction of 4/3. This means that for every 4 items that Rachel collects, Bryce, is that his name? Bryce collects 3 items. Problem 3. A 6th grade class has 12 boys and 24 girls. Circle all the statements that are true. So we want the true statements. So if we have a ratio of 12 boys to 24 girls, we can rate that ratio as 12 to 24, or 12 to 24, or 12 over 24. So what this is telling me is what I would suggest doing is make an equivalent ratio. So when you look at 12 and 24, you obviously see that the greatest common factor is 12. So if you divide both numbers by 12, you'll get another ratio that might help you with these statements. So 12 divided by 12 divided by 12 and 24 divided by 12 gives you 1/2. Oops. Excuse me. 1/2, or 1 to 2, or 1 to 2. These are all the same. That just means that for every one boy, there are 2 girls. So let's go up here and highlight the ones that are correct. For every 2 boys, there's 4 girls. Well, for every 2 boys, there's 4 girls. This means 1 doubles to 2, 1 to 2. 1. So 2 to 4, 2 to 4. So if we have a ratio of 1 to 2, and we double it by multiplying each by 2, 1 times 2 is 2. Oops. 1 time, what is it doing here? Sorry about that. I hit a bad button. 1 times 2 is 2, and 2 times 2 is 4. So this is a correct statement. For every 2 boys, there's 4 girls, because we're doubling. 1 to 2 doubles. B, for every 1 girl, there are 2 boys. Well, no, because we're doing boys to girl. This is boys to girls. Boys to girls, not girl to boy. So it's 1 to 2 for boy to girl, not 1 to 2 for girl to boy. So that's a dud. So let's cross that one off. That's a dud. 12 to 36. So the question here is, this one was a dud. Crossing that one off. We liked A. C, 12 to 36. So if you have a ratio of 12 to 36, if you reduce that by dividing by the greatest common factor of 12, you get 1 to 3, the ratio of 1 boy for every 3 girls. So this is not correct, because our ratio is 1 to 2. Remember, our ratio was 12 over 24, which we found out to be 1 over 2, or 1 to 2. For every 1 boy, there's 2 girls. So we know 1 to 3 is bad, so when we get to D, it says 1/3 of the class are boys. No, 1/2 of the class are boys. So that doesn't work. Let's get rid of that one. 1/3 of the class are girls. No, 1/2 of the class are girls, because half are boys. So there's only one correct answer, and that was letter A. At Parkview, we raised money as part of our Hawk Walk. Last year's goal was $19,000. 19. Try to figure out future goals by using the clues. So last year, that would be the year of 2016-17. And we're on this year right now. So this year, for every dollar raised last year, we're going to raise that by $1.25. So last year's goal was 19,000. So if we take 19,000 times $1.25, because we're going to go $1.25 more, we get 23,750. So $23,750. That's for 2017-18. Okay, the next one asks, in 2018-19, that's next year's school, there's going to be 900 more than last year's goal. So we need to take 23,750 plus 900, and we get 24,650. So it's 24,650. The 2019-2020 goal says for every dollar raised this year or last year, there will be $2 more raised. So wouldn't we have to double that? So we'd have to take the 2018-19 and double it. So multiply it times 2 to get 49,300. So that's $49,300. And last but not least, it says for years 2021, this school's year goal is 3/5 of the previous year. Well, what's 3/5 of $49,300? We multiply the fraction. We multiply straight across, or we can simplify before we multiply. 49,300 divided by 5 gives us, gives us 9,860. 5 divided by 5 is 1. So 9,860 times 3 gives us 29,580. 29,580. That was a good problem. All right, for the spiral review, is 12 a divisor of 48? That means, can 48 be divided by 12? That's obviously yes. Yes. 48 divided by 12 is 4. Right, there's my work. My work would go right there. Is 4 a divisor of 150? Well, we have to see. 150 divided by 4. 4 times 3 is 12. 5 minus 2 is 3. Does 4 go into 30? No, it doesn't go in there without a remainder. So 4 is not a divisor. And there's my work. I would have a remainder. Is 3 a divisor of 51? Well, 51 divided by 3. Yes, 17. Goes in there 17 times. So yes. Choose the number that's not a factor of 300. Well, there's one there that's not. The way I would say to do this is I look, any number that ends in a 0, that's an even number, but we also know that 5 will go into any number that ends in a 0. So that is a factor, because 5 times 2 is 10. 6, well, does 6 go into 30? If we got rid of a 0, does 6 go into 30? Yeah, it goes in there 5 times, and then put the 0 back on. So 6 times 50 is 300. How about 20? Does 20, if I get rid of this 0 and I get rid of this 0, does 2 go into 30? Yeah, it goes in there 15 times. So here's the one that doesn't fit, and I can figure that out without even doing the division. And then let's write the factors of 48. Write all the factors of 48. So the factors of 48, 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. And remember, we could figure out which one's a factor pair. And there they are. And those are your solutions.